Hey guys, how's it going? So today what I want to talk about is how to set up a data lake and a data lake analytics pipeline completely in Kubernetes. So when people think about data lakes and data lake analytics, they typically think about like AWS S3, for example, or EMR, those types of things. So today what I want to do is take a little bit of a different approach and run everything entirely in Kubernetes. Before I get too much into this, I should have just a quick disclaimer that the video is not going to go into any detail about Kubernetes or Kubernetes concepts or anything like that. So it's just going to assume that you have sort of a basic understanding of Kubernetes and Helm charts and those sorts of things. All right, so let's get started. So I've got my Kubernetes cluster set up and running. So if I do kubectl get pods, you can see here it's just a blank cluster. There's nothing on it. So the first thing we're going to want to do is actually set up our data lake. So the way that I'm going to do that in Kubernetes is using something called Minio. Now what Minio is basically it's sort of like the S3 of Kubernetes. It's basically object storage for Kubernetes. And it basically works just like S3 or Azure Blob Storage or any other sort of cloud data lake. The other cool thing about Minio actually is that it actually implements the S3 API. So anything that you have that integrates with S3 and works with S3 can generally work with Minio as well. So that's really cool. So first thing we're going to do is show you how to set that up in Kubernetes. So if we open up our Google here. So Minio actually comes with a Helm chart. So if you do a search in Google for Minio Helm chart, okay, we can click here. And this is the GitHub page for the Minio Helm chart. So it gives you a couple of options for deploying this chart in your Kubernetes cluster and a couple of different ways to do it. So I'm going to use this command right here. So it's helm install, and it sets your access key and your secret key. So I'm going to take this command here, copy it, go back to our terminal, paste it. There's a couple things I'm going to change, just small things. So I'm not going to use generate name because I kind of want to supply my own name. So we'll remove that. And I'm going to call the release name Minio. So basically just like that. So if we hit enter, wait patiently, and there we go. So now if I do kubectl get pods, we'll see we have a Minio pod that's being spun up in our Kubernetes cluster. So we're just going to give that a couple minutes to continue spinning up. Okay, we can see that the Minio pod is up and running here now. So we've got Minio set up in our Kubernetes cluster. So the next thing I just wanted to mention is that Minio actually runs as a service in the cluster as well. So if we do kubectl get svc, we can see we've got a Minio service here that's running on port 9000. So that's the port that Minio's web user interface is exposed on. Also, if we do kubectl get persistent volume claims, we'll notice that we've got a 500 gigabyte drive spun up here as well. Now, if we go back over to the GitHub page for Minio, there's a whole bunch of configuration options we have here at the bottom of the page. So we can actually configure things like the disk size, the number of replicas for high availability, and a whole bunch of stuff here. Now I'm not going to go into the details of any of this. I'm just going to use the default settings, but I just want you guys to be aware that there's a lot of stuff that you can configure with this Helm chart for running it in a production environment. So what I want to do now is I want to access the web user interface for Minio, so this service here that's running on port 9000. Now, if we actually go into our web browser, it's not actually going to work. Now, the reason for that is because we can't access things running in our Kubernetes cluster from the outside. So to get around that, what I'm going to do is I'm going to use a tool called kubeforward. And what that does is it basically port forwards your Kubernetes services and actually lets you access them via their DNS from outside the cluster. So the way you run that is very simple, using sudo -e kubeforward svc. So we run that. And then it starts port forwarding our Kubernetes services. Now if we go back to our web browser here and we type in Minio 9000, we can see now that we actually have access to the Minio service. So I'm just gonna log in here now. So we'll just, if you remember, we set our access key and our secret key here in the terminal. So I just set it to the default thing. So I have my access key and my secret key. So I'm gonna type in my access key, my secret key, and we log in. Here we go. So this is the Minio user interface. It's pretty straightforward. There's not much going on here. You can see right now that we don't actually have any buckets. So Minio actually has a concept of a bucket, which is very similar to, well, it's basically exactly the same thing as an S3 bucket. It's just basically a container for storing like different types of objects. You can kind of think of them sort of like database tables in a way. So we don't have any right here now, so what I'm going to do is I'm just going to go ahead and create a bucket. So we hit plus here, and you'll notice a little button here called Create Bucket. So we'll click that, and it prompts us for the bucket name. So I'm just going to call this something simple. I'm going to call it orders. So suppose we have like a bunch of orders that we want to store in our data lake, so we put them in a bucket called orders. Okay, so we can see over here on the left that we have our orders bucket created here now, and this is a list of everything that's in our bucket. So right now, obviously, we don't have anything in our S3 bucket right now. So what I'm going to do now is I'm going to go ahead and add something to this bucket. So you can do that very simply just by hitting the plus thing down here and hit upload file. So I have this orders.json file here that I'm going to add to our S3 bucket. So before I add it, I just kind of want to show you guys what this looks like. Well, actually, I'll add it first and then I'll show you. So we've got our orders.json file added here. All right, so this is our orders.json file here. So I made this very simple. It's basically just a bunch of JSON objects that represent orders, and every order has two properties associated with it. We've got the ID of the order, which is just like the primary key essentially. And then we've got the amount of the order in dollars. So we've got a $1,000 order, $2,000, and a $4,500 order. So pretty simple. All right, so we've got that in our data lake now. So this is good so far. We've got our data lake now that's running in Kubernetes, and we've got something uploaded to our data lake. So this is really good so far. So the next thing you're going to want to do probably is write an analytics job over this data lake. So analytics jobs are typically jobs that compute things over the data lake. So it could be, like the average order amount, for example, or the total number of orders, things like that. So what I'm going to do here is to do that, I'm going to write a Spark job that's going to compute the average order. So I'm going to show you guys now how to do that. All right, so before we get started with that, the first thing we're going to want to do is actually to install Spark on our machine. So, and we type in Spark download. So we can download Spark from here. So I'm going to go to Spark 3.0. So 3.0 is kind of like the latest and greatest Spark. So if we click download Spark, we'll have a bunch of different options for downloading Spark. So the version of Spark that I'm going to choose for this tutorial is going to be Spark 3.0, just because it's the latest and greatest Spark. And Spark comes packaged with different versions of Hadoop as well. So you can, by default, you can get it with version 2.7 or 3.2. I want to emphasize here that you're going to want to use version 3.2. The reason for that is because 2.7 is kind of an older version of Hadoop, and the way that version accesses S3 is through virtual host style access. It doesn't use path-based access. Path-based access was actually only added in Hadoop 2.8 and beyond. And unfortunately, Minio doesn't support virtual host style access. So if you're using 2.7, it's probably actually not going to work with Minio. You want to use 2.8 or later. So I'm going to download Spark 3 with Hadoop 3.2, which is a much newer version of Hadoop. Alright, so our Spark tar file is downloading there now. Alright, so our download is now complete. So I'm just going to go into my downloads directory. So we can see here we've got our Spark tar file here. I actually downloaded it previously, so this is why there's two versions of it here now, but that's fine. So now we're just going to basically untar that file. So I'm just going to go tar xfz. I'm going to specify the tar file, so our Spark with Hadoop 2.0. And I'm going to specify where I want it to untar to. So I'm going to say user local. Oops, I forgot the dot. TGZ. Oh, and I also forgot sudo. Okay, so we've got Spark now untarred in our directory. So if we go into user local, we should see our Spark folder here. So that's good. So there's a couple of other things I want to do here now. I'm actually going to create a symlink here to the Spark directory. So I'm just going to create a new directory just called Spark and symlink into this version of Spark. So I'm going to say ln-st Spark, and I'm going to create the symlink as a folder just called Spark. Thank you for getting sudo. So let's try that again. Okay. So now we have a folder in here called Spark, which is essentially just a symlink into our Spark 3 folder. Okay. So the next thing we're going to want to do is add the Spark binaries into our path. So normally now, if I type Spark submit, now I actually have Spark added to my path. If you don't, it might be something you want to do. So if you, in my case, I'm just going to go into my bash rc file. Now if I scroll down here to the bottom, you'll notice that I have a Spark home thing set here. My environment variable for Spark home is set here, and then I'm adding this Spark home variable to my path, Spark home /bin. So if you don't have that done in bash rc, I would highly recommend you do that and then run source bash rc. So make that modification. We're going to do source bash rc, and that should change everything for you. That should add that to your path, and then if you write Spark submit, you should get something like this showing up. So that means the Spark submit command is now accessible via command line. Okay. So we've got Spark set up and running. So the next thing I'm going to want to do is actually write our Spark job. So I'm just going to go into my dev folder here. I'm going to make a directory called Spark job, and let's cd into this directory. Okay. So now what I'm going to do is I'm just going to set up a Python virtual environment in this directory. So version of Python that I'm running is version 3.7.7, but this will work with any version of Python. So I'm just going to use the Python-m virtual environment, and I'm going to call it env. So So this is going to create an env directory in here that's going to basically store my Python virtual environment. So I'm going to activate that virtual environment. All right, so we have our virtual environment activated. And now I'm going to install PySpark. So there's different ways of running Spark. You can use different programming languages. So Spark has a Java API, a Scala API, and a Python API. So just for this tutorial, I'm just going to use the Python API just because I think it's probably the easiest one to use, but you can use whichever one you prefer. So let's do pip install PySpark. Okay, so we've got PySpark installed. All right, so next thing I'm going to do is I'm just going to open this directory in my IDE. So I'm using PyCharm here, but you can use basically whichever IDE you want. It really doesn't matter. So next thing I'm going to do now is I'm going to actually create my Spark job. So you can do that in Python. It's very easy. So I'm just going to create a new file here, new Python file. And I'm just going to call it main. You can call it whatever you want, but it doesn't really matter. So now we're basically just going to start writing our Spark job. So just for the sake of this tutorial, it's going to be a really, really easy Spark job. It's basically just going to compute the average order that we have in our data lake. So we're going to go from PySpark import Spark context. Give this a little warning here. And from PySpark.SQL import Spark session. All right. So we're going to create our Spark session. So I'm going to call it Spark equals Spark session dot builder dot get or create. Okay. Sorry, builder. There we go. So that's going to create our Spark session. So the next thing I'm going to do now is I'm going to read everything from our S3 bucket, our orders S3 bucket. So before we can do that, the first thing we're going to have to do is we're going to have to tell Spark where to find our data lake. So the way I'm going to do that is I'm going to define this function called loadConfig. That function is going to take our Spark context and it's going to set up all the config on our Spark context. So there's a couple things that we need to add here in order to make this work. So we're going to have to add our access key and our secret that we set up for Minio, and we're going to have to add the URL as well. So rather than type all that out, I'm just going to copy and paste it here. So this is what we have here. So we have our access key and our secret to access our data lake. I have path style access set to true here. This S3 implementation, that just is the class that defines how to connect to S3. We have our endpoint here, so this is our Minio endpoint, and I've got SSL disabled just for the sake of this tutorial. So this function is basically going to load all these configs into our Spark context. So down here I'm going to call this function now, load config, and I'm going to pass in our Spark context. Alright, so that's going to set up the config. So now I'm going to read that S3 bucket. So the way I'm going to do that, I'm going to put that in a variable called data frame, and I'm going to set that to spark.read.json. And now we specify what we want to read. So the way we specify this is we say S3A, and we say orders/star. Now we don't need to specify the URL for Minio because we've already done that here. So when we write this, it's actually going to look for the orders bucket in our Minio data lake. And the /star basically means it's going to read all files in that order bucket. So we've only got one file in there, but if we had more than one file in there as well, this would work because of that /star. Now what I want to do now is I'm going to compute the average order that we have in this S3 bucket. So how do we do that? So I'm going to say average equals dataframe.agg. So this is an aggregation function. And what I want to do is I want to look at the amount property that we have in our orders.json, and I want to compute the average of that. So this is what's going to compute the average order for us. And just to end off the Spark job, I just want to show the average. So I'm just going to say average.show. So this is probably the simplest Spark job you'll ever see, but it serves its purpose. It computes the average order. Okay, so that's basically it for our Spark job. So the next thing I want to do now is I actually want to try running this Spark job to see if it actually runs. So remember that we still have our kube forwarder running. So that's necessary if we're going to run this locally. So what I want to do now is I want to run Spark submit on this to see if it actually works. So I'm going to do Spark submit and pass in our main.python file. So you can see Spark is spinning up here now. Now the first thing you'll notice is we got an error here. Now, this is expected. It says class S3A file system is not found. Now the reason for that is because there's a couple of other dependencies you need in order to connect Spark to S3. So if you remember, we're specifying the class here, but this class actually doesn't exist. So there's two things we need to download in order to make this work. We need to download the Hadoop AWS jar. We also need to download, I think it's called the Java AWS SDK or something. So let's download that next. And we type AWS SDK Maven. Sorry, Hadoop AWS. Hadoop AWS Maven. So it brings us here. Now, if you'll remember, the version of Hadoop that we're using is 3.2. That's the version that we downloaded. So we'll have to use the matching version here as well. So let's go into our 3.2 and we'll download this jar. So Hadoop AWS 3.2, we'll click save. And the other thing we need is the AWS Java SDK dependency as well. So that's this guy right here. So you can see that the version that this one uses is right here. So we also actually need to download this one as well. So if we click in here, it'll bring us to this page, and we can download the jar for this guy as well. So let's download both of these jars. Alright, so I'm back into my downloads folder here now. And we'll see that we have this Hadoop AWS jar here. And we have this AWS SDK bundle here as well. So now we basically just have to take both of those jars and put them into the directory containing all of our Spark jars. So we'll move them one by one. So we do move Hadoop AWS, and this, remember, is going to go into our Spark directory. So that's user local Spark. And there's a directory under our Spark folder called jars. So we're just going to move it into this jars folder. Okay. So that guy is moved, and now we're going to move the other one. So AWS Java SDK bundle, again, user local Spark jars. Okay, so both those guys are now in our Spark jars folder. Now if we go back into our Spark job directory, now I'm going to try Spark submit again. So Spark submit. I'm going to say main.python, run that script. Okay, so this is awesome. So everything seems to have worked this time now that we have those jars in there. So we actually printed the average order, and we can see it's displayed right here in the console. So this is great. Our Spark job is working. So we've officially written a Spark job that connects to our data lake in Kubernetes, and it's computed the average order for us. So that's great. It's really, really good. So the next obvious thing we're going to want to do here is that, so right now our Spark job is running locally. It's just running on our computer. Now if you're to run this in a production environment, obviously you're going to want to run your Spark job in a cluster somewhere so that you can scale it up, for example. So what we're going to do now is we're actually going to take this Spark job and we're going to containerize it. And we're actually going to run it in our Kubernetes cluster, similarly to kind of how we're running it here. So how do we do that? So to do that, I'm going to take advantage of something called the Spark operator for Kubernetes. So if you search that on Google, the first result should be this page here. So the Spark operator it's a Google open source project that, in my opinion, is probably the easiest way to run Spark on Kubernetes. Basically, it sets up a bunch of custom resource definitions in your Spark cluster. It gives you two basic custom resource definitions. It gives you a Spark application and scheduled Spark application. So you can basically write Spark jobs in Kubernetes like this. You can define this resource called Spark application. You pass it a bunch of parameters, and this will actually run inside your Kubernetes cluster. So this is really, really cool. So for anybody who's running Spark jobs in Kubernetes, I highly, highly recommend you look at this open source project. It's pretty amazing, actually. So what we're going to do now is we're going to install this operator into our Kubernetes cluster. So doing that is incredibly easy, so we just have to add the repo. Now I've already got mine added, but if you don't, you can run this command. And then we simply run this command to install the Helm chart into our repo. So coming back here, I'm going to take this Helm command. And I'm going to paste it in here. Now I'm not going to run it in the namespace Spark operator. That's how they recommend running it, but I'm just going to run it in the default namespace, but it doesn't matter. And I'm going to call this release Spark operator. And I'm going to hit install. There we go. So I'm going to do kubectl get pods. So we can see now we've got the Spark operator deployed into our Kubernetes cluster, and we're basically ready to go. So now we just need to work on containerizing this Spark application. So in order to containerize this, the first thing we're going to need is a Docker file. So I'm going to just go and add a Docker file here. Now, first thing you need to ask yourself when you're creating a Docker file is what you want the base image to be. So if you actually look back in the documentation here as to how they're running their Spark jobs, so they're using this container. So this is a version of Spark that actually comes with the Spark operator. So in this case, it's Spark version 3. So what you could do is you can actually use this as a base container and build your container off of this. I'm actually not going to do that, and the reason I'm not going to do that is kind of important. Let me explain. This version of Spark that ships with the Spark operator has a dupe 2.7 on it. And unfortunately, we're using Hadoop 3.2 because of the reasons I explained previously, because you need to use a later version in order for it to work with Minio. You can't use 2.7. So if we were to actually use this as our base image, it wouldn't work. But that's fine. So what we're going to do instead is we're going to build our own custom version of the Spark image. Now thankfully Spark, actually when you download it, it comes with a Docker build tool for actually building versions of the Spark image. So because we're using Spark 3 with Hadoop 3.2, when we build our Docker container, that's also going to contain Spark 3 with Hadoop 3.2. So that'll be exactly what we want. So let's go ahead now and build our own Spark image. So if you go into the directory user local Spark where we installed Spark to, you'll see there's a bin folder there. So if you go into bin, you'll notice it has this Docker image build tool. So this is actually a script that allows you to build a Spark Docker image that ships with Spark. If you actually search this, so if you look Spark Kubernetes, for example, so there's some documentation here on running Spark from Kubernetes. If you scroll down a little bit, it'll actually explain how to use this Docker build tool. So using it is actually very simple. You just have to run the script, and you have to pass in a repo command, or a repo argument and a tag, and you just run this command, and it basically just builds the Spark image for you. So you can run it using these commands, but if you want to additionally build the PySpark Docker image, you need to run this command, and it also builds PySpark as well. We're going to need to use this one because obviously we're using the Python API, so it's necessary that we use PySpark. So I'm just going to take this command right here, and I'm going to run it. Alright, so we've got our command pasted here, so just a couple things I just wanted to point out. So the repository thing that I'm passing in, which is basically just going to be the name of the image, I just got it called Spark Base, and the tag I've passed here, I just got it called 1.0.0, okay? So we need to actually run this from the root directory here, so let's copy this over. Okay, so let's run our command. Valid argument. Ah, sorry, there's an extra character here that must have got copied unnecessarily, so call that 1.0.0. Alright, so we're building our Spark image. Okay, we can see now that the image has officially been done building, so we have this Spark base / Spark Pi 1.0.0. So that's going to be the base container that we're going to use for our Spark job. So I'm going to take this guy and I'm going to copy him. My mouse will actually let me copy. God, this mouse is way too sensitive. Okay, so we've got that copied. And move back over here. And what I'm going to do now is I'm going to say from Spark base Spark Pi 1.0.0. So that's our Spark base image. So the next thing I'm going to do is I am going to switch to the root user. Now I know people say it's bad to run a Docker container as root, and that is very true for security reasons, but the reason I need to switch to root here is in order to install some Python dependencies, and you can actually switch back to a non-root user after the fact. I'm just going to stay as root for this tutorial, but technically when you're running a Docker container, you're probably not going to want to run it as a root user because it's kind of a security concern. So I'm going to switch to a working dir called app. The next thing I'm going to do, so something I neglected to do here, is we've got our virtual environment here, and what we should do now is we should freeze that virtual environment such that any dependencies that we've installed we can reinstall to a requirements file. So what I'm going to do here now is I'm going to switch back to our Spark job folder. What I'm going to do now is I'm going to go pip freeze. So it's going to freeze our virtual environment. I'm going to put that in a requirements.txt file. Okay, so that's done. So we have our requirements.txt file, so now our only requirements here are PySpark in this case, but you could pull in other dependencies if you wanted to use like other types of libraries with Spark as well, you would install them here. So back to our Docker file. Now what I'm going to do is I'm going to copy this requirements file into our container. And once that's into our container, I'm going to run pip3 install -r requirements.txt. So this is actually going to install all of our dependencies from that file into our Docker container. And the last thing I'm going to do is I'm going to copy this main.python file into our Docker container. So copy main.py. So this is basically our Docker file. This is it. We don't really need anything else beyond this. So now what I'm going to do is I'm actually going to build this Docker image. So I'm going to do docker build -t. I'm going to call this Spark job, let's call it 1.0. And we'll just build it just like that. Okay, so we've got our Docker image built. The next thing we're going to have to do is we're actually going to have to push this Docker image somewhere in order to be able to pull it down from Kubernetes. So let's do that next. So next thing we're going to do is we're going to take this and push it to our Docker registry. So we're going to do docker tag, name of the service, so Spark job 1.0. We're going to do registry.gitlab.com. So I'm just going to push this to my GitLab. Grab 1357, YouTube, Spark job 1.0. Do I have a mistake here? Yes, I do. Should be slash. Here we go. And we'll do docker push registry.gitlab.com, grab 1357, YouTube, Spark job 1.0. So now we are pushing our Docker image. Okay, so it looks like it's officially pushed now. So the next thing we want to do is deploy this into our Kubernetes environment. So I've took the liberty now of creating one of these Kubernetes YAMLs files, similar to what we looked at previously. So if we go back to the Spark operators GitHub page, we just see an example here of how you deploy these types of things in Kubernetes. So we have this custom resource called Spark application, and we have a bunch of things here. We have our Spark driver configuration and how much resources we want to assign to our Spark driver. We have our Spark executor configuration and how much resources we want to use for that, and how many instances of the Spark executor we want to run. We have our image here, and we have the main application file. So I took the liberty of basically taking all these things and creating our own version of it here. So I'll just talk about this a little bit briefly. So type here, this specifies the type of the Spark API we want to use. So in this case, we're using the Python API, and we're using Python 3. The image here is the image that we literally just pushed to my GitLab account. So this is the Spark job image we just created. The main application file, so this is actually the file that we want to run when this spins up. So this is our main file that we created here, if you'll remember. This is what we want to run, so we specify that here using local app main.py. The reason why we have app here is because if you remember in our Docker file, we put everything in this app directory. And this is just our Spark configurations here. So I want to run the Spark executor here with a core limit of 1000 M and memory limit of 512 M. And again, this is our Spark executor configuration down here. So we're going to run 2 instances of the Spark executor, and this is our core request and limit, and then our memory limit here. The other thing I should mention as well here is that I have 2 dependencies listed here as well, and these dependencies here are our Hadoop AWS dependency and our Java SDK, AWS Java SDK dependency. If you remember earlier in the tutorial, we copied those from Maven. We copied the jars and we put them in our Spark jars folder. The reason why I'm specifying these here is because those jars were basically set up locally, and our Kubernetes cluster is not going to have any concept of them or understand what they are. So in order to tell Kubernetes to pull those jars in, we basically just need to specify them here. And if you're ever running a Spark job that requires additional jars, you can add those dependencies here as well. All right, so this is basically our Kubernetes YAML file that we're going to need to run this. So if we come back over here, we run kubectl get pods. So we have our Minio data lake running, and we have our Spark operator. So I'm just going to go back in the wrong directory here. So I'm going to dev Spark job. All right, so what I'm going to do now is I'm going to run this Spark job in Kubernetes. So I'm going to do kubectl apply -f. I'm going to specify that K8s YAML file that we just created. We apply that. It says job created. Now if we do kubectl get pods, we'll see that there's a Spark job being created in our Kubernetes cluster. So this is the Spark driver. Okay, that's finished creating the container. Now if you actually give it a couple of seconds, it'll actually spin up a couple of Spark executor pods as well. So you can wait a couple minutes for that, and you should see 2 Spark executor pods up here as well. So yep, we can see our 2 Spark executor pods now are being created. So we can just wait patiently for those. Okay, we can see that our Spark job is completed and our 2 executor pods are terminating. So everything looks good. So the last thing I just want to do here is I want to check to see that the job completed successfully and actually gave us the correct result. So if we actually want to do that, we can view the logs of our driver pod here. So let's do kubectl logs, pass in our driver pod, and look, you'll notice that it computed the average order correctly. So this is great. We've deployed a data lake in Kubernetes. We've written a Spark job that we tested locally, and then we containerized that Spark job and deployed it and ran it in our Kubernetes cluster. So thanks so much, guys, for taking the time to watch this video. I really appreciate it. If you've liked this content and you've learned something, then please like the video and subscribe to the channel. And if you know of any other cool ways of running data lake jobs or Spark in any other cool or creative ways, please leave it in the comments, and I'll see you in the next video.